So hey everyone, so now we'll be solving a problem A Garland of Educational Codeforces around 145 division 2. So in this problem we are given a collection of four bulbs that is represented by a string, and the ith character of the string will represent the color of the ith bulb. So if we are given a string like 9465, then the color of the ith bulb will represent, like, the character, this ith character, it will be the color of this bulb. Okay, so if we look over here now, initially in this question it was provided that all of the bulbs are off, and in one operation we can either turn it on or we can do off. Okay, so you might be thinking like, yeah, if we just need to turn it on, like, then we can just simply turn all of them as on in one go. But the problem is that we cannot turn two bulbs, two bulbs of same color consecutively. So we cannot color two bulbs of same color consecutively. So let's see a case for that. So if we are given a string like this, 36. So if we turn, this was the initial state. If we turn this fourth bulb on, now we can turn on this fourth bulb because it is again of the same color. We can turn these two, any of these two. So we can turn this on now. Now we can turn this on because for this its previous is 3. So we can turn this again on, turn this on. So how many operations does it require? It requires 1, 2, 3, 4. 4 operations. Now for this it requires only 4 operations. Again, why? Because if we turn on this, we can turn on any of them, then again, because there are four distinct bulbs of four distinct colors of bulbs. Now, and here there are three distinct color of bulbs. Now, the what are the all possible cases? Either there could be four distinct colors, three distinct colors, two distinct colors, one distinct color. If there is only one distinct color, like all of them are same, then it is not possible. Like if I turn uh, fourth, this is the first bulb. All of them are zero. It is not on. It represents the number zero. All of are the same color. Okay, and all of them are off. So I can turn on this. Then I cannot turn any of them because they all are the same color. So it is not possible. In that case, I can simply put -1. So for this case, it answer is -1. For all fours, like if there all the characters are of different color, like there are four distinct colors. So if there are like this, 1, 2, 3, 4, all of them are of distinct color, then only four operation I do require, right? I've seen here. So here four operations are required. If there are three distinct colors, like if there are 4, 4, 3, 6. Here also I require only, in this case I have seen only four operations I require. For case of two, let's see the case of two. When there are two distinct colors, right? Now, what are the all possible cases for two distinct colors? Now, if there are two distinct colors, then there could be of one color repeated two times, and the second color it could come also two times. Or what can happen? The first color it appears one time, and the second color appears three times. Now, these are all the possible cases, right? So what in these two cases? Like in this case, when there are two distinct colors and both of the colors appears two times, like 4, 4, we can see in this case, like there are two distinct colors and both appears two times. So in this case, first I will turn this on, then this on, then this on, then this on. Because I can turn this, then I cannot turn this on, but I can turn these two. From this, I can turn this on, then I will turn this on. So then again, it requires four operations. For this case, we will again require four operations. These are the sub problems for that, right? For the fourth one. In the case of two distinct color, we have again two cases, right? So here we require four colors. Now let's see this case. when there are when the first color is appears three times and the second color appears single time, then we can color this, then we cannot color these two. Like initially all of them are off, right? And now what can I do? I can turn this on, then I can only turn this one on. Now from this I can turn this on, but now all of them are on. Now I can only do operation with this four, because for the consecutively I cannot do operation on same color of bulbs. So from this, after this, I can only perform operation on this bulb. So I can turn this off. So after performing operation on this, I can turn this on. Now again, I can turn this on. Now, how many operations are required? One, two, three, four, five, six. Six operations are required. Now, these are all the cases. Now, if I am having four distinct colors, then my answer is four. If three distinct colors, then four. If only one distinct color, then answer is minus one. And for a case of two, now the case of two also have a sub cases, right? So, for if only two, if there are only two distinct colors, then the first color might appear two times, and the second color might appear two times, or the first color appear one time and the second color appear three times. So for that, their answer will be 4 and 6. So this is there are these are all the cases that we have to consider for this problem. There's no need to applying any loop for that. Simple if else statements. So the code will be provided in the description. So I hope this problem is very enough clear to you. If you are having any doubt, you can post your doubt in the comment section. Yeah, thank you.